So we will continue doing problems on chapter 2. We will start by this question. So first write Lewis dot symbol and give the resulting compound for Ks elements first and ALO elements second. So as a first step, we should go to the periodic table. In the periodic table, we can see in which group are the elements we are interested for. So for the first two elements, we have K and S. Okay, so this is K here. K is in group 1 and S is in group 6. So it's clear that you have the combination of one metallic element with another non-metallic element. So we have the formation of an ionic compound. Now, since K is in group 1, so it will tend to lose one electron. And in general, the representation of an ion can be done in this way. I put the brackets, I put the element, then I put the corresponding charge. So it will give ion K plus. Okay. Now, in order to show the difference between a positive ion and a negative ion, for a positive ion, I don't put dots here inside the brackets around the element, since I consider that it has lost the electrons on its outer orbit, while for the ion that that has negative charge, which is S here, S tends to lose 2 electrons to give S2 minus. So I have the following. I have, if I want to present ion S, I present it in this way. So S, and I put 2 minus. But in addition to this, I put the 8 electrons, showing that he has he has gained 2 electrons to complete its outer set of 8. So I put it like this. Okay, and now, since I have 2 negative charges for S, I need how many atoms of K? I need 2 K atoms, because I have 1 positive charge for K and 2 negative charge for S. So if I want to complete the configuration, I will put another K from the other side, another K ion. So this will be the representation of the ionic compound. So it will result in the ionic compound K2S. Okay. If I want to put it in a summarized way, I can put it like this. I can put it as 2 K plus, like this, 2K plus, and S 2 minus. Okay. And since S is gaining electrons, I present the full set of electrons after gaining the 2. So I put for S 8 dots. Okay. So this is how I do the Lewis presentation for an ionic compound. Now, the second type of ionic bonding I am studying is between. So they ask in the second question.
Doctor?
Yeah. Yes.
If we represent the 8 electrons on the outer shell for both atoms بيأثر شيء؟ طبعا نضيع أيها نعملها؟
هلا هن عادة they only present على الاتوم اللي ربح electrons. Okay, so it's just a way to say that this is the one who gained electrons, and the other one after losing electrons اللي كان عنده outer orbit يعني outer orbit راحت. In this meaning they don't put the dots for K. But if you want, of course, if you want to represent the planetary model for K, of course you should put the dot points. Okay.
Okay,
it's not wrong. If you just take K plus, you can put no. Now the outer orbit of it will be of 8, but he lost the outer one. اللي كانت على بالأساس. So when you put them in brackets, okay, without dots, this means that on the outer orbit الأساسية you don't have electrons. This is the meaning of this.
Yes, okay, thank you.
Okay, well. So now for ALO element, okay, also we will go to the periodic table and see what are the groups of the elements involved. So we have aluminum here, it's in group 3, so it tends to give us Al3 plus, and the oxygen atom, which is in group 6, which tend to gain 2 electrons. Okay, so the ions involved are Al3 plus and O2 minus. Okay, so here, what is the corresponding numbers needed? So how many aluminum atoms should be combined with how many oxygen atoms?
2 and 3.
Very good. Yes, 2 and 3. Very good. Because if I have 2 Al, okay, 2 Al can give 6 electrons. Okay, and in this case, I need 3 oxygen atoms to gain. So I need 3 O to gain 6 electrons. Okay, so the resulting compound will be 2 Al2O3. Now, if I want to present the detailed structure, I have 2 Al. So let me put it here if you want.
Best doctor, I have a question. This is
Yes.
an ionic bond?
Yes, it's an ionic bond, of course. Okay. In general, whenever you have a metal with a non-metal, you have an ionic bond. There is some exceptions, but you are not responsible for in case you have not enough energy, because you know that to create an ion, you need to provide a certain energy in it for to form the ion. Okay. In case the energy is not enough, you will have a covalent bond, but the covalent bond will be not fully stable because you cannot reach a full set of 8. This is the example I sent you on the WhatsApp group, a certain article on BF3, which we studied last time. When we studied BF3 last time, we said that if we do covalent bonds, okay, we have that in this case, B will reach only 6 electrons on its outer orbit, which is not fully stable because it's need 8. This is why we can say that ionic might be better. But to say that ionic bond will take place, you need to satisfy another condition, that the energy provided is high enough, okay, to create the ions. So, and you are not responsible in this course. We will not go into these small details. And you are not responsible of calculating energy and to know if the ionic bond is possible or not. This is why when I give you cases, I will not give you exceptional cases. So whenever I give you a case of a metal with a non-metal, it will be an ionic bond. Okay. So here you have, if you want, when you have groups 1, 2, 3 combined with one of the other groups 5, 7, 5, 6, 7, it will be ionic. Okay. While if you have 2 atoms both having groups higher than 4, so it will be covalent. Okay.
Okay, thank you.
Well, so here we have for Al and F. Okay. For Al and O, sorry. If you want to present in detail, as we said, we have 2 aluminum. So let me draw it here for you. Okay, so I have the first aluminum atom, and this is the second one. Each of them can give 3 electrons. So this is 1, this is 2, this is 3. And also for the second aluminum, it can give 1, 2, 3. So I will have 3 oxygen atoms And for each one already, you know that the oxygen atom already has 6 electrons on its outer orbit. So 1, 2, 3, 4, 5, and 6. Okay. So for example, here I will put, since I need 3 atoms of oxygen, I will put them. Okay, so it seems I have one in between here, let's say, and one down. Okay, so and each one has 6 electrons on its outer orbit. Now what will happen, for example, for the oxygen that is above, he can take 2 electrons from the first Al, but the first Al will still have 1 electron, so he can give it to the middle oxygen. Okay, and now for the middle oxygen still need 1 electron, so he will 1 electron, so he will take it from the second Al atom. So if we can represent the the electron transfer, it will be like this. We have 2 of these electrons. These 2 will be given to the first oxygen atom. The first Al still have 1 electron. It will give it to the second oxygen atom. Now the second Al will give 1 to the second oxygen atom to reach a full set of 8, and the 2 remaining 1 will be given to the third atom. So this is how the electron transfer will take place. Now if I want to represent the Lewis presentation for the ionic compound, so after this, on the outer orbit, Al will lose its electrons. So we can represent it into brackets like this with 3 plus. Okay, so we have 2 Al elements with a charge of 3 plus. And in parallel here, we have 3 oxygen atoms with a charge each of 2 minus. Okay. And of course, don't forget, since now oxygen will gain the electrons, we should present the set of 8 dots around O. Okay, so for each oxygen, we will put the 8 dots around. Okay, so I will do it for 1, and we should repeat it for all atoms of O like this. Okay, this will tell you that the outer orbit is full for O, while for Al, he lost his last orbit because he don't have any more electrons on the last orbit. Okay, so this is now if you want to put it in summary, to not put it in detail, the molecule, you can just put it like this. So you can put it's 2Al 3 plus. Okay, and then they will tell you, if they tell you draw in detail the configuration, you do this one. If they tell you put the summarized presentation, you put 2Al 3 plus and 3 O 2 minus. Okay, and don't forget to put the dot around O because it has completed its outer orbit. Okay, like this. Okay, any question on
Yeah.
this?
Yes.
Yes.
This the last representation شو اسمه؟
هيدا ال summarized Lewis presentation of the ionic bond. وهيدا is the detailed, I will write them here. This is the detailed Lewis presentation of the molecule of the ionic compound. Okay, and this is, if you want, this is the summarized Lewis presentation. Okay, And sometimes, if we just want to put the molecule, if we just put the molecule name, okay, you can put it like this, just Al2 and O3. Okay, that's it. Any other question on this?
Thank you دكتور. والأولية اللي رسمناها على الشمال ما لها اسم؟
لا، هيدي إذا بدك it's the scheme of transfer of electron. Okay, هيدي the scheme of electron transfer. Okay. Okay. Now, let us continue. Okay. A second problem. I will put the detailed solution for you, okay, when we are done. Okay. So, draw the hydrogen bonding structures for HF, H2O, and CH3OH. So, whenever we talk about hydrogen bonds, we have two conditions. We should have we should have H present in the molecule, and H should be in connection with a highly electronegative atom. The three electronegative atoms are N, O, and F. You know that electronegativity increase when moving like this, okay, and increase when moving up. Why when moving up? Of course, in this, when moving to the right, why it will increase? Because the number of electrons on the outer shell is increasing. But why if we move upward, then the electronegativity will increase? What is the reason?
Radius decreasing.
Yes, because the electrons will be closer to the nucleus. And since in this way they will occupy a smaller volume, so they will create a denser negative charge. Okay, this is why we say that the most electronegative elements are these three, N, O, and F. Okay, and whenever H is combined to one of these three, we can say that hydrogen bonds can take place. And hydrogen bonds are a particular case of dipole-dipole interactions, because it relies on creation of positive and negative dipoles that will attract each other. Okay, so let us see, for example, if we have H and F, how will be the hydrogen bonds? Okay, so first, if I draw the molecule H and F, I have a certain bond between H and F, like this. Okay, so I have, you know that F is of group 7, so already it has 7 electrons, so it's a high number, which will create a negative dipole, okay, and it will share the electron number 7 with H. So already, whenever you have pair of ions, this will create an electronegative charge. So we can put here that from this side, from the side of the ion pairs, from the opposite side of the covalent bond, we have a negative dipole. And the negative dipole charge is represented like this, delta minus. While for hydrogen atom, the 2 electrons are from the side of F. This is why this side of hydrogen will be charged positively. Okay, so you will have 2 dipoles of opposite charges. From the side of H, it's delta plus. From the side of F, it's delta minus. So this will allow hydrogen bonds. Hydrogen bonds will take place between the pairs creating a negative charge and the positive dipole of H. So, and hydrogen bonds are represented by dashed lines. Okay, like this. And now from this side, I will have another hydrogen atom due to another molecule. So this is the delta minus dipole of F will attract the delta plus of another hydrogen atom in another molecule. So this is plus delta. Okay, and in this way, H is a hydrogen of another molecule HF, and this can be repeated in an infinite way. Okay, because F itself has a negative charge, so it can connect with another delta plus, another positive dipole of hydrogen. So I illustrate a dashed line connecting to another molecule HF, and this can be repeated for a high number of molecules. Okay, so this is a hydrogen bond, and this is how we can illustrate. Okay, now the other molecule we will study is the second molecule is H2O. Okay, for H2O, what will happen here? We know that oxygen is of group 6, and H needs 1 electron to close its set of 2. Okay, so for H2O molecules, each oxygen will be connected to two hydrogens. So if I want to present it, let's say this is my first oxygen water molecule. So this is oxygen, and it's related to two H molecules, 1, let's say, and 2. You know that already O has, so these are shared electrons. O has 4 electrons that are just for him. They are not shared with any other atom, which will create, so these pairs of electrons, whenever you have pairs of electrons, they will create a negative dipole. So here you have delta minus, okay, a negative dipole charge from this side, and you have 2 molecules, H here, 1 here, and 1 here, and both will have a positive dipole. So I can put it like this. So this is plus delta, and this is also plus delta. So now what can happen is that this element O can connect with another H from another water molecule, and it will be a hydrogen bond, since O is one of the highly electronegative atoms. So I put it like this. This is H, so it will connect with the positive dipole of a hydrogen of another water molecule. So H is here, and this is another H is from another OH2 molecule, so I represent the second molecule. So this is oxygen, and I have H. Okay, so I have the other hydrogen down. So this is H. Okay. Now, of course, this can continue infinity of times. So, for example, this H plus can do hydrogen bond with another oxygen from another water molecule. So I can represent here another hydrogen bond by a dashed line connected to another oxygen atom. And of course, it will we will have attraction between the negative charge and positive charge. So we have here an oxygen atom, which is a part of a OH2 molecule. So this is 1H, this is a second. And of course, here you have the pair of ions that will create the negative dipole charge, which will attract the, so here let's put them as dots, which will attract the positive dipole of H. Okay, so and in this way you can have millions of hydrogen bonds between water molecules. Okay, any question on this? So let us move to the final example. In the final example, we want to represent hydrogen bonds and molecule CH3OH. So I have the oxygen atom. We know that the oxygen atom has 6 electrons on its outer shell. So it can connect with 2 other atoms. Why the connection, one of the connections should be with C? Because if we have 2 connections with H, we obtain H2O, and it's not anymore possible to do a connection with C. Okay, this is why we should have a one connection with C and the other connection with hydrogen. So we can see here that one of the bonds will be with C and the other with H. Okay, so here this is H and this is CH3. I just represented here CH3 in summary. If you want to expand it, you can put C with C can share 4 electrons, so it's 1, 2, 3. Okay, and the first connection will be with O. Okay, so we can put it like this: H, H. Pay attention, bonds will not be with hydrogen of C. Bonds will be with hydrogen connected to oxygen. Pay attention for this. So hydrogen bonds always take place with hydrogen connected to the highly electronegative atom. Okay, so here if you want to put in detail the molecules, this is your molecule, and this is an additional H. Okay. But you can summarize it here like this because CH3 will not interact in the hydrogen bonds. So hydrogen bonds will be only between H the hydrogen connected to oxygen. So here, if I want to put the dipoles, I have, due to the pairs of ions, I have a negative dipole charge from this side, and I have a positive dipole charge from the side of hydrogen. So this will allow to create hydrogen bonds between several molecules of CH3OH. So if I want to represent possible hydrogen bonds, okay, so let me do some. I will put it from the upper side because here, okay. So let's say the negative charge of O will connect with a positive charge of H. So I will have a dashed line representing hydrogen bonds. So here I have another H of another molecule. Okay, it will connect with, of course, the positive dipole side. Okay, and then this H belongs to another molecule, so it's connected to an electronegative O. So as you can see, the bond always takes place between the hydrogen that is bonded to the highly electronegative atom. Okay, with the other oxygen of the other molecule. So here, this is another molecule. This is CH3.
Doctor, it doesn't matter الangles ما هيك.
لا يعني I will not for the angles, don't worry about it لأنه it's a complex thing to يعني you need to go through a procedure to know the angles. يعني for me it's fine. مهم تعرفوا تحطوا البونز. Okay. هلا in general for oxygen صرتوا تعرفوها إنه oxygen will have an angle nearly of 60 degrees between the 2 covalent bonds. بس إنه you don't have sorry 120 degrees. Okay, you don't have to go through these details. ما ححسبكم على الangles. Okay.
Doctor,
Yeah.
H around C
Yeah.
aren't considered hydrogen bonds.
No, look, the H around C cannot do hydrogen bonds because the condition is the hydrogen that can do hydrogen bond should be related to the highly electronegative atom, يعني or O or F or N. Okay, so you cannot do a hydrogen bond with the H connected to C. This is the rule. for hydrogen bonds. Okay, why? Because H that is connected to O will have a more positive dipole charge, since O is highly electronegative. Okay.
Okay, thank you.
So now this oxygen in turn can interact with another molecule in the same procedure. And from this side, H plus here also can connect to another oxygen from another molecule. So this can be repeated in infinite ways. Okay. So for example, this H, let's say, will connect to another molecule. So for example, like this. Okay. This is dashed lines. We'll do a hydrogen bond with another molecule. So this is O from this side. This is O. And of course, this is the electronegative. This is the negative dipole. So it's minus delta. Okay. And you have here the molecule of CH3 and H. Okay. And this will be repeated. It will be repeated several times. It can take place infinite times. Okay. Any question on this? Okay. So this is for hydrogen bonding. Now you asked me to give examples for metallic bonding. So we will do some examples on the metallic bonding. So for example, okay, if I tell you, for example, to draw metallic bonds, let's say between Mg atoms. So if you have several Mg atoms and you want to draw an example of metallic bonding, what is nice about metallic bonding, you have several possible presentations. Metallic bonding can involve different numbers of atoms. You don't have always the same number. It can be, let's say, between 4, between 10, between infinity of atoms. But the presentation can be done for any number. So for example, if I tell you you have a block of 4 atoms of Mg, and I tell you draw the corresponding atomic metallic bonds. Okay. So what you will do, let's say I have, for example, I can give you 4, I can give you 9. Let's say it's 9. Let's say it's 9 atoms. So you draw 9 atoms close to each other. And as you know, Mg tends to lose 2 electrons to reach a stable set. And in this case, it will have 2 positive charges. Okay, so for each atom, it will be positively charged with a charge of +2. So if this is my representation of the block of 9 atoms, and when losing their electrons, they become charged. So I will put here for each atom a charge of 2 plus, 2 plus, 2 plus, 2 plus, 2 plus, 2 plus. Okay, now since I have 9 atoms and each having a charge of 2 plus, so in total the number of electrons that are shared by them is equal to 9 times 2 to 18. So all you have to do is to disperse electrons in this block of atoms in a random way. Okay, so these are the electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so you can put electrons just in a random way around these atoms. This is the metallic bond. Okay, this is a metallic bond between ions. Another example, if I tell you, for example, draw metallic bond between a block of 4 atoms, let's say of aluminum. Okay, of aluminum, for example. I have 4 atoms of aluminum. Aluminum tends to lose 3 electrons to give a nion Al3 plus. Okay, so if I have 4 atoms of Al, so 1, 2, 3, and 4. Okay, and since it tends to lose the 3 electrons, so each atom will be charged with a 3 plus charge. So 3 plus, 3 plus, and 3 plus. It will result in these atoms will lose in total 4 times 3, 12 electrons. So what I can do, I can put 12 electrons shared between them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, this is called a cloud of electrons shared between the different atoms. So this is for metallic bonding. So it's the easiest type metallic bonding. You can have, yes, why not? You can have, if you have several atoms and all of them are metallic, yes, it's possible. They can share electrons together. But in general, it is, it will be it's more frequent with one atom, because in this way, if you want, you will have the same structure. The atoms of the same structure will tend to go with each other. Okay, but yes, it is possible. Why not? Okay. So now we will do a last question. I will tell you to give examples of dipole of molecules with dipole interactions. So with dipole bonding. Okay. You remember what is the definition of dipole bonding? What is dipole bonding? Dipole bonding is a type of bond that will take place between molecules with dipoles of opposite charges. So it's very close to hydrogen bonding, but the difference is that I don't have hydrogen connected to one of the electronegative element. I can have any other connection. So in the course material, the example given was a connection between H and Cl. So it's true that this molecule contains H, but it will not perform hydrogen bond, because hydrogen bonds can only take place with one of the 3 most electronegative atoms, which are NO and F. But the concept is the same. So if you have HCl molecule, or if I give you another example, any other atom in group 7. So if I take I, for example, okay, or F, all are valid. So if I take H with I, let's say, if H with F, it will be hydrogen bond. Okay. If H with I, it will be dipole bonding. So let's say I have H and it's connected in a covalent way with I. Okay. Then, of course, I has 7 electrons already. So it has pair of ions, which will create a electronegative dipole from the side of I. From this side, I will have a negative dipole. And here it's a positively charged dipole for hydrogen, since the electrons of hydrogen are from